In this video, I've got a combination clipper circuit, and I've got a sinusoidal input of 10 volts peak to peak in series with a 1K ohm resistor in series with the parallel combination of diode D1, a 3 volt DC source, and diode D2 and a 3 volt DC source and a 100K ohm resistor. And now at the start of the cycle, the plus 5 volt peak goes into the circuit through the 1K ohm resistor, through diode D1, and through the 3 volt DC source. The output is plus 3 volts DC plus 0.7 volts across the diode, a plus 3 volt DC plus a 0.7 volts across the diode, and that equals 3.7 volts peak. Now on the negative input, the negative input goes through the 3 volt DC and through the diode, and the output signal is minus 3 volts DC minus 0.7 volts minus 3 volt DC minus 0.7 volts across the diode, and that gives you an output of minus 3.7 volts peak. And now at VL1, this is what is going on across the resistor. Notice how you have some areas across it where it's 0 volts here, 0 volts here, and 0 volts here. This area is called crossover distortion. The crossover distortion is caused by the diodes. Now here you have 1.3 volts peak. This 1.3 volts peak is caused by the positive input. So how do you determine this? This peak is found by adding plus 5 volt peak, then subtracting 3 volts DC minus 0.7 volts, and that will give you 1.3 volts peak. Now on the negative cycle, minus 5 volt peak plus 3 volts DC plus 0.7 volts, and that will give you an output across the resistor of minus 1.3 volts peak. Now I want you to take a look at the shape of the output. Notice how it seems to be approaching a sinusoidal shape. And that's because as you increase this voltage and this voltage, the output will become closer to looking like the input. And this brings me to the end of the video. Like and share the video, and thanks for your attention.